Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
We're live. If you were listening before, you might have heard that Professor Clark is from the University of Washington, where he actually is in the Department of Sociology and is a sociologist, and is making extensive use of tools like SQL Server in, I would say, fairly non-traditional ways, in particular doing social science simulation that model various kinds of policy interventions in fairly important issues like the transmission of AIDS. So with that, I'd like to hand it over to Professor Clark, and I hope you will join me in welcoming him here today. So thank you.
Great. Thank you. The title of my talk today is Relational Databases in the Social and Health Sciences, the View from Demography. And I'm going to start with just a brief introduction of myself. I was born and grew up in East Africa, and that'll help you understand why I have such a focus on Africa in the work that I do. I was trained as an undergrad at Caltech in biology and engineering and applied sciences. Most of the biology training was in neurosciences and most of the engineering in computer science. So I have a little bit of background there. Then I went to graduate school at Penn and did a PhD in demography. So that's where the social science component comes in. I'm currently at the University of Washington. And my main interests are African demography, which is the structure and dynamics of populations, in my case looking specifically in Africa, modeling the impact of HIV in African populations, and developing data management methods for tracking human populations with particular interest in health issues. So this is a summary of my talk. I'm glad you all showed up, by the way. Thank you very much. I'm used to talking to academics, students, and complete lay people. And I didn't quite know what to expect here today. So I have a variety of things. I'm going to tell you a little bit about some of the work modeling and simulating populations that I've done. That work uses both Access and SQL Server, so it touches on your environment a little bit. I'm going to talk about longitudinal studies in the developing world, health and social studies. These studies use all kinds of data management tools, in particular SQL Server, and I've spent a lot of time thinking about how to better use relational databases in those environments. Then I'll talk briefly about archiving and management of social science data, data analysis and mining in the social sciences, and finally education and training, and then a little bit of fantasy about what we would like to see happening. Okay, so starting with modeling and simulation. Effectively, what I want to do is model an entire population and use this model as a heuristic tool to help me understand how the whole system functions. In other words, how all the pieces at various levels are interacting with each other, all the way from sub-individual, that is cells, all the way up through the population. So we have cells, people, population. I'm not trying to be accurate in terms of reproducing any given population, but rather use the whole thing as a virtual sandbox in which I can study the system. So the idea is to create a whole population through time with realistic demography, and that includes the vital dynamics, the birth and death of individual people, and good marriage dynamics. Who's hooking up with who, and what are they doing? Are they having kids? Are they not having kids? How quickly do they have them? And so forth. And then finally, adding HIV at the individual level, so that we have a within individual incubation of the disease. You get infected, you go through the first part of the disease that's relatively asymptomatic, and then toward the end you get AIDS, you get real sick, you start behaving very differently, and you die. To do this, we have to have transmission, both horizontal between adults through normal heterosexual sex in Africa. That's the predominant mode of transmission. And then vertical transmission, which is from a mother to her child. And then that can happen through the birth process itself or through breastfeeding. And then finally, the interesting bit, modeling interventions that do something to affect this whole system. Okay. So the tool that I developed is a structured population event history simulator. It's an individual level stochastic two-sex simulator. So it models all those things that I just described. In addition to polygynous marriage, that is multiple women per man. And in lots of African settings, you have marriages that are this way, more than one woman per man. Very important when you're talking about sexually transmitted diseases to take into account the non-sanctioned relationships that exist. So those are non-marital relationships. And then, of course, we have to have the disease progression at the individual level, which reflects the person's trajectory through an HIV illness. Let's see, how do we get this to go? There we go. Okay, so this is the bit that we can talk a lot more about if anyone is interested. The entire simulator is built around a relational database that both generates and manages the data that are simulated. Now, surprising to almost everyone will be the fact that it's MS Access 97. And this is because I started this work, I think, in about 98. It took me about 3 years to build. At the time, I didn't have either the time or the resources to really learn an enterprise-level RDBMS. 97 was there. It turns out to be pretty handy, and it's not the fastest thing in the world, but it actually does this. So I used Visual Basic for applications and the SQL that is implemented in 97 to execute all the logic associated with the simulator. It generates full histories and records those histories for every individual so that I can go back and analyze the interaction of individuals over an entire simulated period. Something that's very nice and is different from a lot of other modeling strategies is that these simulations can be stopped and restarted. So you can simulate a bunch of years, you can stop it, change parameter values, do a bunch of things, and then start it up again. And obviously it can take both time varying and constant parameters. And it can also generate parameters on the fly, things like the prevalence of HIV, and then feed those back into the dynamics of the simulation. The core data model is right here. You can see it's a pretty simple thing. We have people here. We have unions, both marital and non-marital here. We have links between people and unions. That can be the spouses and the children produced by the union. We have fertility events right there in the middle. These track the fertility history of each woman, conceptions, miscarriages, births, end of breastfeeding, and so on. These are pregnancies that have to be tracked in order to take into account the effect of HIV on pregnancy and the fact that it reduces the ability of women to carry fetus to term, which obviously impacts on fertility a lot. That's the core data model. There are about 100 other tables in this database that manage the parameters and then the outputs from the model. But the real core is just that simple. So there are a bunch of modules here to govern dynamics. We have a fertility module, a mortality module, 2 modules that deal with marriage, one that deals with regular marriage and one that deals with non-marital unions. A very important module at the bottom is sexual intercourse. The model generates sexual intercourse events that lead to both conceptions and the transmission of disease. And HIV affects fertility, and a lot of the interventions that affect HIV also affect fertility. For instance, condoms. If you intervene with condoms, you have a big impact on the transmission of sexually transmitted diseases. You also prevent a lot of births. And if you don't take all of that into account simultaneously, you wind up with a model that doesn't reproduce what actually happens. And then finally, there's a module to deal with HIV. The time scale here is 1 month, so we're dealing with a time granularity of a month. For sex, we deal with a time granularity of 1 day and accumulate it over a month. I just went over that. These are some details on the HIV module. Parameters. A simulator of this sort takes a lot of data to parameterize it, to actually feed in all of the rates with which people do things, have sex, get married, get divorced, whether or not having 2 kids affects your divorce rate versus 3, 4, and so on. All of that data comes from a very detailed 40-year study of a population in southern Zambia, where they tracked 10,000 people for 40 years and literally kept track of everything. So I had very rich data to parameterize this, except for the non-marital unions. And as you can expect, not very many people are willing to openly discuss what they're doing extracurricular. We have some vague information about this. Now we actually have some much better information, but when I did this, we didn't. And effectively, I made this up, and I generated those parameters so that the entire thing reproduced the broad demographic behavior of the population. For instance, the growth rate, the fertility rate, and the mortality rate pretty much matched reality, even with these things in there. And then finally, HIV impact. There's lots of good measurements of what HIV does to individual people and to populations. Calibrating it, these are the things I matched: overall growth rate, sex ratio, fraction married, fertility, mortality, and nuptiality. So those things in the simulator match the same things in the Zambian population from which the parameters come. Okay, now I have two examples of studies that have resulted from running the simulator, two questions that I looked at, and I'm going to skip over these right now and move to a couple other topics and maybe come back if we have time. So I'm going to switch gears here a little bit and tell you about a couple other modeling exercises in the kind of social and health sciences world that use, specifically use SQL Server actually as the underlying enabling technology. The first here is the Actuarial Society of South Africa's AIDS model. It's called the ASA model. Somewhat unfortunate acronym, but there it is. This is a very important model in the Southern African context. It's used to model the entire population of South Africa. It uses a cohort component projection framework, which breaks down the population by age and by sex, and in this case also by geographic region and by race. And then further by behavioral category, people who are pretty much heterosexual and faithful, people who have a lot of partners, prostitutes and commercial sex workers of various sorts, and so on. The idea is that we're able to project the entire population of South Africa into the future, predict the number of people who are going to be HIV positive, predict the number of HIV AIDS-related deaths, predict the number of kids who are going to be infected, predict the age structure of all of these things, and feed all of this back into the people who have to make decisions about how much care needs to be provided, who needs to get it, where it needs to be provided, and so on. The original model was actually implemented in Excel, and when you hit run, it took it still takes about 6 minutes for a run. Then there's a version which is written in C++, which takes a very small fraction of a second to run the whole thing. And when you can run it in a fraction of a second, what you're tempted to do is run it hundreds of thousands or millions of times with lots of variations so that you can study uncertainty in the results. And when you do that, you end up with a tremendous amount of data that you've generated, and then you need a database to store all of that stuff and sift through it. So SQL Server is now being used as the back end to manage both the parameters and the results of those model runs. If anyone's interested, there's the link to go look at that model. You can download the Excel version. Another much more high-profile population-related institution is the UN's Population Division in New York. They have a model which they called Abacus DIM. Don't ask me why, but this is the name of the model. It's another cohort component projection model. Does essentially the same thing as the ASA model, except they have to do this for every single country in the world every 2 years. They have to produce 100-year projections. So they have a very large amount of data that they need to manage in terms of parameters for those, in terms of predictions that they make. They have to do actual forecasts, so they have to have a high, medium, and low for every country for 100 years. And then they have to publish all of this stuff, and they have to add it to their backlog of archived projections, which they then compare themselves to as time goes into the future. So they've been doing this for a long time on mainframes using COBOL and things like that. And recently, within the last 2 years, I think they have switched entirely to using SQL Server to manage the data and VB to actually execute the logic of the model. And as far as I know, they're extremely happy with that kind of architecture. Okay, now another switch in topic. Now we're going to look at longitudinal studies, and instead of looking at generating data and modeling processes, we're going to look at collecting data, real data, and storing it and analyzing it. So longitudinal studies are probably more familiar to you as temporal. These are studies that span a long period of time, and they're very common in the population and health sciences. Examples are demographic surveillance, panel studies, repeated linked cross-sectional studies, cohort studies, anything that follows the unit of analysis through time. All of these involve observing units of analysis, usually individuals, recording their histories and often recording the relationships between people over long periods of time. So the basic idea is that you're able then to make some kind of a statement about cause and effect, because you know at point A, condition X prevailed, and a period of time later something happened, and you can relate those two things to each other. Okay, the data management requirements are interesting. These studies produce large amounts of complex temporal data. They often last for periods of decades, which means several interesting things happen. Technologies change radically. So what you started with in terms of a data management technology is not what you have available now. So you have legacy data issues that are sometimes very serious. In addition to that, the requirements of the studies change. So you may have started out as a vitamin A trial in Ghana, and now you're doing HIV vaccine trials. So the substantive nature of what you're doing is also completely different. And a lot of these studies right now are being developed and generated in the developing world, where the overall infrastructure for managing data is poor. The basic IT infrastructure is not so great, bandwidth is very low, and so on. So there's a big challenge involved here, both in terms of how to manage this data and increasingly where it's managed. Hello?
So I have a couple of questions. What exactly, how large is large? Like,
how large is large? These range from about 10,000 people to maybe 300,000 people. Some of them are only 2 years old, some of them are 40 years old, some of them are 60 years old. So if you have 200,000 people that you visit, say, every 2 weeks for 60 years, you have a large data set. It's in a well-normalized form. It can be gigabytes size, several gigabytes. If you do that in an unnormalized data model, I mean, it can be hundreds of gigabytes. Even small data sets that may say monitor 10,000 people over 5 years, if you don't have it in a well-normalized data model, it can be many, many gigabytes.
These are the observational data sets. The simulation data sets must be orders of magnitude. I guess one of the issues I think I'm hearing is multiple gigabytes is not large.
Yes, for you guys.
For us. Right. But the simulation models must generate terabytes.
They could easily generate terabytes. Usually people don't keep terabytes. This is one of the big problems. Okay, so this is something I wanted to bring up a little bit later, is that there's a fundamental disconnect between basic IT professionals, like some of you are, and most of us who are working in the social sciences. I'd say we're at least 2 or 3 decades behind where IT technology actually is. Most of my colleagues would think that a 500 megabyte data set is big, unmanageably big in some cases. So anyway, we'll get to that in a minute. So we have data models and standards for one type of this data, the so-called demographic surveillance system data. Let me see. Yes, here we are. So I'm just going to talk a little bit about what exists in the field. Right? Sorry.
In the earlier slide, when you make the statement that you don't have a solution, what exactly do you mean? Is it that
what I mean,
how is it like what's the complexity of the problem? Is it like assembling the data in a database, or after you assemble the data, once you have the data in the database, like putting it to use in some form? Which is a hard one.
Most people can put the data into a database. The problem begins to make itself known after the data get into the database. The number one issue is that the databases are not structured in a consistent way. So there's no standard in terms of how the data are structured. There's also no standard in terms of the semantics of the data. Similar data are defined differently. So it's fine for the one study. Those guys can kind of manage their own data. They can kind of analyze it and deal with it. What people want to do increasingly is pool these data, put them together, say combine data from a site in India, a site in Bangladesh, a site in Nepal, and say something about the Indian subcontinent. And the way they're structured right now, these data are very difficult to work with and do something like that. So what we're talking about is pretty much from the data input step onward, thinking through much more systematically, developing standards, and developing software systems that people could essentially use off the shelf and do what they need to do here. What's happening is everybody's developing their own system. So everything is developed in an ad hoc, idiosyncratic way by local developers who have varying degrees of ability, background, education, and so on. And it's basically a big mess.
Is another dimension of that the fact that it's only recently that there's a migration to what we would consider to be sort of state-of-the-art IT and data management tools?
Yeah, and the migration hasn't even started in a lot of cases. And people are still using DBase. Some people are still using text files. Some people manage their data in statistical packages, not databases at all. So part of the idea is bringing everybody at least into the realm of the modern data management. Okay, so I'm going to tell you a little bit about the state of the art here. And I'm going to use the demographic surveillance system as the organizing principle. There's something called the reference data model, which was developed by 4 colleagues and myself in 1998. None of us having any real training in relational database design. And we put together this data model that would be able to manage the basic elements of a demographic surveillance system, which are birth, death, marriage, divorce, and migration. It's a reasonable little data model. It has been incorporated into something called the household registration system, which is the de facto software that people use for demographic surveillance. In retrospect, it's a very bad design. We didn't know what we were doing. It's absolutely fixed. There's no metadata layer. It's totally unflexible. In terms of its relational structures, is bad. It's relatively simple. Everybody who uses it has to modify it. So basically, they have to break down the code. It's an open source thing, so everybody can tinker with it. Everybody tinkers with it, does something slightly different, makes it incompatible with their neighbor, and moves on. It's also implemented in FoxPro. And I don't know what you guys think about FoxPro, but my personal opinion is that it has limits, pretty serious limits in terms of the quantity of data that it can manage and how well it does at doing that. So we're trying to get people to get out of FoxPro, but many people are still stuck there. Okay. Now, I'm going to talk about one thing here. So the Structured Population Event History Register is our first attempt to be more systematic about this and design some core concepts for a data model that would do a better job. So here I'm going to tell you a little bit about demographic surveillance, a little bit more than I have just now. It monitors a geographically defined population for long periods of time, records everything to do with births, deaths, in-out migrations, internal migrations, so we keep track of people moving around inside the area, marriages and separations, and then in most cases augments itself with a whole bunch of other information related to health and social science. So intervention trials, drug trials, vaccine trials, chronic disease monitoring, cause of death investigations, and you name it. People add new investigations to these DSS sites. And in terms of social science, people study things like the relationship between economic indicators and people's decision-making at the household level. So what happens to a household when somebody dies of HIV, taking into account all of the streams of income that that household might have and all of the expenditures that they might be dealing with. Okay, so we need an effective solution to manage all of these data that are generated. They're strongly temporal. The sites are long-lived. Specifications change over time. Technologies change over time. And at the moment, no effective solution really exists. And like I said, people are very, very interested in being able to pool, share, and compare these data. In fact, I know that they're not linked to you guys, but the Gates Foundation has solicited from us an application to develop a system of this sort because they see it as a key stumbling block in terms of developing countries' ability to monitor the health of their populations and develop in a timely fashion new interventions. Okay, so we need something that's going to effectively manage DSS data at single sites and at many sites at the same time and allow those data to be standardized enough to be put together, analyzed together, and quickly produce some kind of a result. Okay, so the existing temporal frameworks are pretty much, how do we say? There is a lot of theoretical work in terms of temporal databases, but as any of you know who've worked with relational databases, not much of that has actually seeped into the production systems. So all of this nice theoretical work around interval-based data, pretty much you don't find that functionality in SQL Server or Oracle or DB2 or anything else. So we have the ideas floating around out there. We don't have the implementations that would be really nice. So we're struggling with designing relational data models that allow us to do some of that with the tools that we actually do have. So the aim here is to present a general conceptual framework to unify the representation of time and structure of the population. Okay? So we want to develop a temporal data model that's general and hence flexible and extensible so that it's going to have a long life, live for decades in these sites, maybe move through several generations of relational database management systems. We want to try and adhere to this idea of a metadata-driven data specification that can be updated and extended without having to change the underlying hard structure of the data, which would lead to something like schema invariance. And we need to be able to accommodate and manage data from multiple sites efficiently and provide a means through which to rapidly implement new data management modules. So if we have a metadata description of what we need to do, we can share that metadata with other sites, have them loaded up, and be able to manage those new data in exactly the same way across lots of sites. Okay, so time, I don't know if any of you have really gotten into time. It turns into philosophy at a certain point very rapidly. It's universal, it's one-dimensional, it's dense, unbounded, difficult to precisely conceptualize, measure, and manipulate. When we started getting into this, a colleague of mine and I, we read a lot of physics papers about astronomical time and real time and how they interrelate and all kinds of stuff. Essentially, what we have to worry about are two types of time. Events that mark changes between different states. So those are something that happens at a very well-defined short duration period of time. And then states, which are long intervals between events during which some constant state of being is maintained. And there are a few others, but those are the primary things we're interested in. So the temporal entities, the states, everything that we want to consider in these DSS sites has a valid lifetime, so that makes them states. They have a well-defined beginning, a well-defined end, and a constant meaningful mode or condition of being in between. And they can be either tangible physical things like people or intangible things like marital unions. It turns out you can generalize all kinds of things into this idea of a state. So they're associated with everything that's constant. Then we have the events, which bring about change and mark the beginning and the ends of these states. And they occur at a well-defined point in time, bring about some change. And the change influences one or more states. And it's important here because events influence lots of different states, and through their joint influence on many states can encode the links between states, so the relationships that exist between states. So examples that we're interested in are births, deaths, weddings, observations, and movements. And then the third element of this idea is the influence. And an influence is an explicit representation of the link between a state and the events that influence that state. So influences represent the influence of a specific type of event on a specific type of state and are linked to exactly one state and one event, and together form many-to-many relationships between events and states. I think I'm going to skip over this diagram. Essentially here, no, maybe not. What we have here is a very simple example population. So we have in green, sorry, the laser here is a bit, I can't really see it. There we go. So the green horizontal bars are states, the blue vertical bars are events, and the little red dots are the influences. So you can conceptualize this kind of temporal system as things that are persistent through time, events that change those conditions, and links between the events and the states coded by those little red dots. So in our relational data model, we are going to have three basic tables, one to store each of those three elements. Okay, so that brings us to the structured population event history register, which is a relational database schema that implements this event influence state concept. And it's a very general idea. It can be implemented in any relational database. And it's metadata driven. Those three things are very general. in order to specify specific events, influences, and states, you have to be able to have a second layer of data which defines the domain for each of those three things. And then you can form links between the actual, I want to say, incarnations of the general entities and the metadata that describe them. So this gives you a very flexible and relatively simple way of recording the temporal evolution of a connected population. Okay. The metadata are not new to you guys at all, but are very new for some reason to social scientists. In fact, the word is totally foreign. I have to explain it to those guys most of the time. And it's an important thing here because it gives us the, I'm not going to go through this in detail. Essentially, the metadata, as we all know, give us a kind of malleable description of what's going on, and then you can write routines that utilize that metadata and generate specific actions based on the metadata. So it's nice and useful. Okay, we'll skip through those. Here's an actual schema. I've built a couple demonstration databases that implement this and seem to do a pretty good job. I can calculate all of the things that normally need to be calculated and store all kinds of different data in this one schema without having to change the underlying structure. Just to touch on the fact that if you follow it through in detail, this is a normalized data model. And in particular, it's very important, from my point of view, that the timestamps appear in only one place, that is in the events table. One of the big stumbling blocks in these kinds of data management systems is that dates get distributed all over the place. And as time goes by, people add new tables, and they put dates in those tables, like a date of birth or a date of death. And that same date exists in 3 other tables in the database. And when someone goes to edit or update those dates, they remember one place, or the developer remembers to write a trigger that updates 3 out of the 4 places. And over the course of a few years, you wind up with a database that's literally totally unanalyzable from a temporal point of view. In fact, I know several projects that have just had to go back and re-enter everything because it unravels so badly. So this is important that the dates are in one place, you update them in one place, and then through the links they get reflected all over the place. We don't need to worry about that. Because we now have a standard data structure, the metadata allow us to have standard semantics for our primary data. We have the ability to share data very easily and also to pool data very easily, which is very important to developing multi-site studies and multi-site interventions. Okay, there's the multi-site idea. There's several things which are missing here. The first is metadata-driven integrity constraints, especially around the temporal entities in the data model. And referential integrity in relational databases is a bread and butter thing. Temporal integrity is not, and especially being able to enforce temporal integrity in a normalized structure. So we're still working on that. The other thing we want to do is develop metadata-driven representations of questionnaires and link those metadata and the data they collect in the database. So in other words, you have something like a language which describes the data input machine that you use to acquire data from people. In our case, it's usually a questionnaire. So you have the elements and you have the layout. We want to be able to store that, then go out and use it to collect data, and then store those data and store a link between the data and the instrument that collected the data. In our case, a single question may change over time, and how people administer the question may also change over time, and that influences how people answer the question. So we want to store all of that together so that when someone goes to analyze the data, they can look at the data, then they can look at the question that elicited the data, see how that changed over time, control for whatever biases may be introduced by that, and carry on. We also want to be able to present these data collection instruments on PDAs, on paper, and via an HTML interface. So we want to be able to have the same representation manifested in several different ways and give us flexibility in terms of how the data are input to the database. And then one of the biggest problems that we're facing is once the data are all happy and consistent in the database, how do we get them out and give them to analysts in a way that they can do something with them? It turns out to be a huge problem, again, because statisticians are usually not trained in data management. We can't give them a relational database. because they're going to hack it up and they don't know what to do with it. So we have to make flat files for them, and we have to make them in a very structured way that can be fed into the statistical packages that they use and analyzed well. The disconnect between the people who do the SQL to get the data out and the people who analyze the data is really severe. And the communication that happens there is very poor, usually results in a multi-round iterative process where you request a data set, it's not right, you request it again, maybe it goes through 10 iterations before the person has a data set they like. It's a big waste of time because these SQL programmers are expensive and scarce, and it's something we want to try to address by developing automated, kind of wizard-based ways of creating complex analysis data files. Okay. There's some example databases. Okay, now I'm just going to run through a few things quite quickly. The first is archiving and management of large social science data sets, large in quotes again for you guys. There's something called the Data Sharing for Demographic Research Initiative at the University of Michigan. There's a link there at the top to that. This is an initiative in response to another initiative by the National Institutes of Health, who in 2003 published a comprehensive data sharing policy. Any project that is supported with public money through the NIH has to make their data available in a timely fashion to everyone. And there is an actually large amount of data produced by all of the projects that are NIH funded. And I have to say, they are better on average than most social scientists, the ones who run this data sharing initiative. But they're still not completely, I think, up to the minute in terms of technology and practice in data management. So we still have a lot of linked flat files with a lot of repetition. We have trouble getting data sets in a form that analysts can use them. They're very good at cataloging and documenting. I'm not sure that they're great at presenting and indexing, allowing you to search it. Anyway, this is going on. It's a relatively big data store, big storage, lots of data available there, and increasingly using relational databases. There's something called the in-depth network. This is a network of DSS sites predominantly in the developing world. There are about 40 of them right now, mostly in Africa, quite a few in Asia, several in Latin America, and one or two in Eastern Europe. These sites have identified this lack of a solution that works for everybody as a major problem, and we're preparing a proposal to create a new piece of software to try and address this. And that software will, in particular, look at the capture of data using both paper and PDAs, particularly wanting to look at PDAs for lots of reasons: reduced cost, increasing quality of data captured, ability to capture other kinds of information like GPS coordinates, biometric measurements, and so on. Trying to address issues of data quality, storage and manipulation, with a great emphasis on extraction and analysis, and then another big emphasis on archiving, taking all of the data and making sure it gets into a searchable electronic archive with links to the original capture instruments. Perhaps the biggest requirement here is making sure that we can share and pool the data, and that implies developing standards, which hopefully we're on the road to doing, but could probably use a lot more work. We're envisioning about $20 million necessary to do this, and hopefully we're going to get a consortium of the Gates Foundation, the Wellcome Trust, and the NIH to pay for that.
Over what period of time?
We want to work with professional software developers to develop the spec for this and then hire a programming house to do it as rapidly as possible. We're thinking 2 years, 3 years.
So 20 million over the 3 years?
Yeah.
Okay, so that's not a per year figure?
No.
Okay.
No, in total. But I have a hunch that this is the ballpark at the very front end of this process. I think it's going to grow. And these endeavors have a very, very dubious history. I don't know if any of you are familiar with the National Health System in the UK that has already spent, I think it's around £10 billion on a national hospital and clinic and patient record management system, which is basically going down in flames right now. I know that HP was working on a big one a while ago, and I haven't heard anything about that for a while.
Another one, not health, but obviously another population surveillance kind of technology. Yeah. But they just scrapped theirs and are going to start again after several hundreds of millions of dollars.
Exactly. So it seems deceptively simple to do this, but the track record is that it's very hard. And we're amateurs. We'll see what happens. But there is a clearly defined need, and there are a lot of very, very interested parties. All of the foundations, the NIH, WHO, UNAIDS are all very interested in trying to make this happen and make it happen very quickly. Because essentially all of those dollars that you hear about being spent on HIV and malaria and TB have to have some evidence base to allocate them. And the evidence base is just remarkably thin, and people are really worried about that and want to augment it rapidly. Okay, data analysis and mining in the social sciences. Extraction of analytical data sets from complex temporal databases is difficult, requires usually that you have a pretty skilled SQL programmer. Pretty skilled SQL programmers who are willing to work for academic wages are pretty rare. So there's a big problem there. It's a big bottleneck for most of these longitudinal projects, and there are very few people in social science who have the skills and kind of history with relational databases to be able to do this effectively themselves. In fact, I know of exactly 3 people like that. I'm one of them, and I have 2 colleagues who I know who are actually social scientists who can do well enough with this to do this kind of thing. So we need a number of things. We need standard data structures and routines for analysis, and most importantly, we need more people who are trained in both the substantive area and data management. That is the theory of relational databases and some SQL skills. Okay, data warehouses in the social sciences. They don't exist. Yeah.
Would you see that as an issue for how you train social scientists, or do you see it as an issue for how the economy pays computer scientists, or if it is what?
I see it as an issue of both. Basically how you train social scientists. I think that's the first issue. And then the second issue is how you pay social scientists. And maybe there needs to be, I mean, I think if people are going to take on board skills like this, then maybe we're just going to have to pay them more. Everybody says they want this. And now we're at, well, I'm just beginning to get to the point where I can talk to deans and people who can actually make decisions about money. And what I'm telling them is basically you've got to pony up more dollars to compete with industry. Okay, so data warehouses. This is a technology which truly does not exist in the social sciences as far as I'm aware. SAP, I worked with SAP in South Africa on a project which is attempting to develop a data warehouse for demographic surveillance. And it's my opinion, there's no product yet, and I'm very skeptical about their ability to produce one. I think they've totally underestimated the complexity of what they're about to do. And that's being borne out by the fact that they're floundering around now for the 5th year with nothing on the verge of coming out. Okay, so this is an area I think that is just ripe for all kinds of development. And at least it's ripe for making people aware that this area of information science exists. Education and training. What we're doing at the moment, we have a master's in field epidemiology that we support at the University of the Witwatersrand in Johannesburg in South Africa. And as part of that, we have a 3-week module on relational databases and SQL. And I teach that. And we run people through the relational model of data, SQL, common data models for DSS, and how to write SQL. And as far as I know, it's the only formal database training module in the social sciences anywhere. And it's actually in public health. I don't know of any that exist in North American-based universities. At the UW, that I know quite well, there's absolutely no training available in data management in the social sciences. Elsewhere on campus, obviously, you can get training like this in a computer science department, information science. But there, what they're going to do is take you through relational calculus and all kinds of theoretical things. which people in the social sciences don't need. They need to understand enough of it so they can write good SQL and do the work that they need to do, perhaps design a little database. So in other words, you can't shoot a statistics graduate student over to computer science and have them take the course over there. It's basically a waste of time. So we need to have a different kind of training that's available to people in the social and health sciences. Down here we have, in health science, we have informatics classes, which basically teach people how to interface with existing hospital management systems, patient record management systems, and things like that.
The geographical information systems people are facing the same
They
kind
are.
of issues, or
People-
are they being able to solve some of that?
People get trained over there in how to use a GIS system, ESRI or one of the other ones. Usually if you ask them to move out of that and then even link to our kinds of data, you wind up with the same kind of problems. You have to hire a programmer to help you. And the problem is these programmers, many of them are great. They're kind of expensive, but they have no idea about the substantive nature of what you're trying to do. So it is truly hard to communicate with them and get a product in a reasonable period of time that's satisfactory. Okay, what we need. We need more education in data management principles for scientists in training in social, behavioral, and medical sciences. From Microsoft, it's great that we now have these express editions of SQL Server and Visual Studio. In terms of making things happen in the developing world, we need cost structures that are appropriate for those places. Some of these projects just can't afford SQL Server licenses, so they use one of the free products, MySQL or whatever. And I'm not partisan here, but what I don't like about those systems is that they are not well documented. They're hard to use, and that's where you guys have a big advantage. I mean, some people may argue about the quality of the documentation, but pretty much it is documented, and you can figure out how to use it. Okay, and then my point at the bottom here is that we still need lots of basic research on interval-based data, temporal and spatial, and implementation of systematic principled methods of managing such data in a normalized form, including regular automated integrity constraints that would allow us to automatically and regularly make sure that things are sequenced in the right way, make sure that everybody's marriages, for instance, happen within their lifetime instead of overlapping at the beginning or the end, making sure that people die after they're born. All these things are big problems, and I would like to see a database system where I could implement checks like that, just like I do referential integrity, where we could set it up nicely, have the DBMS check those things automatically. Okay, those are my contacts. So we're sitting at 4:30. How are we doing for?
Good time for Q&A.
Good time for Q&A. I can show you some results of simulation if you'd like, which are fairly interesting. Okay, let's go back and do that, and then we can have Q&A.
For example, you told us a story the last time you visited several months back
About the non-intuitive implications of various interventions.
Okay.
Maybe that would, oh, there you go.
So here we have,
Very interesting.
I'll try to run you very quickly through two results from the simulator. So to cross all the T's and dot all the I's, this is done with an undergraduate student of mine, Jeff Eaton, who did most of the actual grunt work for this study. This is just a distribution map of the prevalence of HIV in Africa. The vast majority of HIV-positive people globally live in Africa, and the vast majority of them live in southern Africa here. That's just to give us some perspective. There are a number of observational studies that indicate that male circumcision can influence the risk of transmitting HIV from males to females. Okay, sorry, from females to males. So starting from this point, people have argued that it would be a great thing to circumcise all the men in southern Africa. And there are so-called circumcision Nazis who are absolutely attached to this viewpoint, that this is the golden bullet, the silver bullet, whatever, that'll solve the HIV epidemic. There is now recently a well-designed, well-constructed, well-done clinical trial in South Africa that has shown that circumcision reduces the female-to-male probability of transmission by about 60%. So the adjusted relative risk is 0.39.
They went out and circumcised a bunch of guys randomly.
Yes.
Okay, just checking.
It was a randomized...
Yes, hence not double blind.
It requires awareness.
Yes, the blind part, is that still in there? That should not be there. You definitely know when you're circumcised. So male circumcision as an HIV intervention strategy. We know now from the clinical trial, just one at the moment, that there is an individual level effect. The question now is whether or not this effect would aggregate up at the population level to have a significant impact on an epidemic. Okay? There are other details. Could you actually do it? Is it socially acceptable? Is it logistically possible to go out and circumcise a whole bunch of guys and so on? The short answer to those things is yes. People appear to be willing to be circumcised, and it's about $20 a pop and can be done in large parts of southern Africa. Okay, so the real question is, does it have a population level effect? So here's a little quote by one of my colleagues, and he is poo-pooing that in fairly direct language. I'll let you read it for yourself. So my question to you, would you be happy having your wife or yourself using a birth control strategy that was only 60% effective? Would you do that if you really didn't want to have a kid? No, you wouldn't.
I mean, there are other incentive structures, right? I mean, there are some religious commitments that others may have or some may have. But,
exactly. So here's the point. The questions are, how many circumcisions would you need to perform before being able to substantially decrease the prevalence of HIV, in other words, have an impact on an epidemic? What is the impact of an intervention that targets only adults, and is there an impact on females in the population, given that this intervention should directly impact only males? And in which subpopulation of males is male circumcision going to be most efficient? So what we're going to do is simulate a bunch of different scenarios, 3 different age groups. We circumcise at birth, or between the ages of 10 and 13, or between the ages of 18 and 24, and at 4 different levels, 10% circumcised, 25%, 50, and 75. We're assuming here that a baseline 7% of men are circumcised, which is a fairly decent assumption in southern Africa. So this is an additional 10, 25, 50, or 75%. Here's the HIV prevalence in a control epidemic. Along the horizontal axis from 0 to 129 are years of the simulated epidemic, and this is HIV prevalence. That is the fraction of the total population that's HIV positive. At the beginning of the epidemic, you can see this big upswing. This is the females, and they plateau out here at a little less than, well, it looks like about 22%, and the males at about 18. We won't go into why the difference is there, but that is a real difference and has to do with the age difference between partners. Okay, here is the at-birth intervention. We have the control group, 10, 25, 50% saturation, circumcising at birth starting in year 30 of the epidemic. We started at year 30 because the epidemics in southern Africa are all mature epidemics at this point, so there's no point in looking at what happens in the beginning. You can see that it takes a while for any real effect to materialize, and then there's virtually no difference between the control and the 10% group, and there's only a relatively modest reduction even for the 75% group. The reason it has this big lag, that big lag is about 1 generation, because it takes these guys from birth until they become sexually active for any effect to materialize. And here, the deal is that 60% protection just isn't enough to protect you over a long period of time with a high number of cumulated exposures. Okay, so at most, we're getting a, what is this, about a 18 to about 13, about a 5% real magnitude reduction in HIV prevalence. Okay, so the next question is, does the male circumcision intervention affect the prevalence and incidence for women and children, or is it just for men? So here we have the female HIV prevalence with the at-birth intervention. It mirrors the male effect almost exactly, and that, if you think it through, that's how it should work. If you have fewer males infected, they're producing fewer secondary cases in the female population, and you should get a reduction. And it's of a relatively similar magnitude. Again, up until about 10%, there's no effect at all. Here's the vertical transmission for kids with the at-birth intervention. Again, there's a lag and a very similar magnitude, reducing the probability of transmitting a virus from the mother to the kid because the mother's not infected at all in this case. Most people would consider these fairly disappointing results, I think. People were looking for much, much bigger results. Okay, and now what happens when we initiate the intervention in different age groups? So does the magnitude and the effect of male circumcision depend on which age we circumcise, and does the age and circumcision affect the time horizon of the impact? And it should, as we know. So here's the teenage intervention, again in year 30. And what we see is that we begin seeing the impact of the intervention right away, and that's because we're intervening with people who are just becoming sexually active, so that makes sense. The overall final impact is about the same. Here's the male HIV prevalence adult intervention. Right, so now we're only intervening with adults. This is young adults, 18 to 24, and we have an immediate impact, and the final impact roughly the same. Here's the prevalence prevented for the 50% coverage for males. So we have the at-birth intervention in solid blue, the teen intervention in pink, and the adult intervention in yellow. This is the residual prevalence, the control minus the intervention. So this is the amount of prevalence taken away by the intervention. You can see that for the adult intervention, it kicks in right away, goes up to about here and stabilizes like that. For the teenage intervention, its time scale of kick-in is intermediate, and it goes up to about the same level as the at-birth intervention. The at-birth intervention takes about a generation to kick in, and then goes up here. In all cases, it's restricted to less than 4% in the real magnitude difference between the control and the intervened epidemic. So the take-home message is you're going to have to start hitting all three age groups simultaneously to get a quick effect. You're going to have to do it for a very long time to get this 4% reduction in total prevalence. So I think that disappoints most people. We've seen results from another model that doesn't use this technique, uses a deterministic model, and gets almost exactly the same results. So we think this is in the ballpark of the right numbers.
See the similarity between your type of data and data generated by drug trials?
Yes.
And if so, how are the drug companies addressing the disconnect between the relational database problem and...
Drug companies have another challenge. The data management procedures used by drug companies are mandated by things like the FDA and the EU. In other words, to certify a drug, you have to adhere to a certain set of procedures and principles, basically. And so they have a very well worked out way of managing data. Basically, it's very simple what they do. The kinds of data that they deal with are much simpler. Essentially, they take a population, they define everybody at the beginning, they follow those same people for a relatively short period of time, they give some of them the drug, they give some of them a placebo, and they just follow them up, and they don't care about anything, basically, except what happens vis-a-vis the illness that they're trying to intervene on. So the structure of their data are simpler, and the way that they're managed is prescribed by these regulatory bodies. So the problems that they face, basically, are how do we efficiently manage the data and meet the criteria set forth by the regulators. Our little system that we want to put together needs to meet those regulatory mandates as well, because a lot of the studies that are being planned in these DSS sites are drug trials. So we may not actually do the drug trial, but the drug trial will use our data as part of the data that they generate. And so we have to comply so that we can participate in those things. So, yeah.
Keep the data in relational databases, or do they put it in statistical?
They do both. They manage it in relational databases, although access is expressly prohibited because of the fact that its indexes can and do corrupt, and it doesn't give you any feedback about that. And then it literally generates totally random stuff, and it's impossible to tell what's real and what's not real at that point. Both FoxPro and Access will do that. So basically they specify which database management systems you can use, and then they give you a format for the data, and then they give you a procedure for how to get it in, how to log it, how to correct it, how to document it, and how to analyze it. So it's a completely canned thing.
Is that issue with Access limited to 97?
No, it's in 2000 as well.
I see. And how do you deal with that, or is that why you're migrating to SQL?
That's why we're migrating. Well, there's two reasons to migrate to SQL. That problem doesn't exist. The size limitations of Access are another big problem. And then transaction logging in Access basically doesn't exist. Well, it's kind of there, but kind of not there. The multi-user experience with Access is not a good one. Yeah. So, yeah, those are the reasons. Okay. So those simulations that we just saw were done in Access. What you saw was an average of 3 stochastic simulations per line, and each of them pretty much maxed out Access, I think.
You would run a simulation in Access, actually. I mean, what's your rows? What's your columns?
The tables are the ones that I just showed you, pretty much. You say, for instance, you want to model death. You have a probability of dying at each age for each sex, modulated by your HIV status and maybe some other risk factor. You just chunk the person through life 1 month at a time. If they're still alive, you expose them to the probability of dying that is associated with their age and their sex and their HIV status. You generate a random number. You compare it to their probability of dying. If the number is less than that probability, you kill them.
I understand how you run a simulation. The question is, how do you interpret that as a series of tables in Access? Is each row a person?
There's a table with people. There's another table with unions. There's another table with links between those. So, in other words, you generate new people and add them to the people table. When they get to the right age to marry, you expose them to the risk of getting married. When they actually do get married, you generate a new union in the union table, and you make a couple links that link them to the union. And then as time goes by, that union ages. You let them have sex. They have a kid. You link that kid to that union too, and you put the new kid in the database in the people table. And essentially, for all of the events that you want to model, you use that same strategy. And as you need more entities, you add another table to keep track of those entities. It was actually through doing the...
So when a person dies, is that an additional, for example, is that an additional row, or is that the person's status is now changed to dead, which means that you lose their past?
No. You have a record in the people table, which includes the date of birth, the date of death if they died, and some control value if they're still alive, either null or something that you've agreed upon.
Let me pick an example that happens more than once in life.
Mm-hmm.
Say
a birth.
A birth or sex or whatever, yeah.
Mm-hmm. So for births, there's a table in there which holds all the fertility events for women. Birth is a fertility event. Basically, a woman's reproductive cycle starts with being fertile. She has sex until she conceives, if she's not contracepting. When she conceives, she can gestate up until she has a miscarriage, an abortion, or a birth. After birth, she can either not breastfeed, or she can breastfeed for a period of time, stop breastfeeding, recover from all of that, become fertile again, and go through that cycle many times. So you just record those events, all of those events that mark boundaries in that cycle in one table, link those events to the woman, and to the union, and to the pregnancy, which you also record. It's not too bad.
Okay.
Basically, the same database that you would use to record all of this stuff empirically on a real population, you use exactly the same database, and you write update queries that generate the data instead of just capturing it.
And the big difference is you've got all these parameterized tables that are the probability of these events, whereas in the real world you just let
Right.
those probabilities be manifest in reality.
Right. So the empirical procedure is go out, collect the data, store it, analyze it to generate the probabilities that you then relate to whatever. You just reverse the process exactly to simulate the data. And that's exactly my mental progression in doing this. First I collected data, and then I thought, yeah, it might be easier to generate it. And in that way, study all of the ways that things can interact. Okay, so let's stop there. You want to see the rest of it? It'll take another 10 minutes.
Old people.
Okay, old people. Okay, see you then. So we'll just go through quickly. Impact of just you.
I'm interested.
Impact of HIV on the elderly in Africa. So the questions here are, how does HIV change the structure of the population in which the older people are living? Are there significant impacts on the sex ratio? What happens to the dependency ratio? How many orphans are created? And then how many of these old guys are left around to look after them? So we run 5 different scenarios. No HIV as a control epidemic, untreated HIV to look at the impact of the epidemic itself, and then 3 different treatment scenarios, a behavioral treatment, an antiretroviral treatment, and a combined treatment. We run each of these starting in year 31 of an epidemic, do 3 simulations each and average them. So first we're going to look at the trend in the annual proportional growth of the population. These 3 lines are male, female, and both. Again, simulated time here, years 1 through 40, and annual percentage growth on that axis.
This is net increases in population, and this is under no HIV. You don't have essentially a death tax, and the population grows between 3 and 4.5%.
That's right.
Okay.
And it just stays that way. I've simulated about 2,000 years before this, so this is a completely stable population and has a stable growth rate. So it's just
at that rate of 4% a year over 100 years, you more than
oh yeah. Population grows very rapidly.
When you say stable,
well, it's a stable rate of change.
No, it's a stable age structure. That's what we mean. It's stable age structure, stable marriage structure, all of the internal components of the
relative
population.
proportions of components in the population are relatively stable.
That's right.
Okay.
Precisely. But the actual total size is growing rapidly. Here's what's happened when you add an HIV epidemic. The red line is the female prevalence, blue line is the male prevalence, and you can see that the population growth rate begins to decline after about 10, 12 years when people start dying, and declines right down to 0 or thereabouts, maybe slightly below.
so the population is going to
Disappear. Right.
You're on a track to do total annihilation.
You're on
They
track to
go clean out an entire nation, leaving no one behind.
This is an epidemic which is very similar in magnitude to the epidemics in Botswana, Lesotho, Zimbabwe, and Swaziland right now. And they actually are getting down to near 0 growth rate right now. And if and a population can't stay below 0 very long.
How long?
Probably about 3-4 generations.
Oh, okay. So we're
doing 80 years.
80, 100 years, 150 years is probably, it's effectively gone.
okay. So then that ethnic population simply where it just disappears.
Yeah, so big problem. So this is the overall big problem, is that just the raw size of your population, could stabilize but could actually shrink. And if it shrinks for very long, that's doomed. Okay, so what happens when you intervene with a behavioral intervention, and what this does, removes all of the extramarital relationships. So all of the extramarital...
I mean, this isn't something that's practical. This is just assuming we could create saints.
That's right. Assuming overnight we could make everybody into a saint, what would happen? And the motivation here is to see in general, what kinds of things happen and what would be the biggest magnitude of an effect. Knowing that in reality, you may not be able to do this at all.
Okay, so this is a
boundary condition.
This is a boundary condition. So you would get an immediate reduction in prevalence. This is because you don't create as many new cases, but the cases that exist keep dying. And you have a very bad negative effect on the growth rate because not only do you prevent the transmissions, but you prevent the conceptions as well. So this is a big disaster, this kind of spike in the negative direction on the growth rate.
Luckily, humans are highly resistant to this. They'll never accept it. So that never happens.
Well, in places like Uganda, they've done some of it. They've been able to get people to change their behavior. Not everybody, but probably 15, 20% of the population, maybe even more.
Is that literally not engaging in extracurricular?
It's probably mostly changing the way you engage in extracurricular. It's condoms, and it's also sequential monogamy rather than concurrence. Yeah.
Okay.
Yeah. So that's so you can do something that approximates that, which is not bad, and that's a very good intervention. It really slows down the production of new HIV positive people.
The serial monogamy.
Serial monogamy, using a condom, having fewer extra partners. Yeah.
Okay.
Here's the antiretroviral treatment. Has a totally different kind of effect. Prevalence actually goes up.
So more people
Get infected
Right.
because there's more people walking around to infect.
People live longer in an infected state. They feel better. They have a lot of sex, even though their viral load is suppressed. The fact that they live so much longer, have so many more contacts.
lower incidence,
More frequency,
Right.
effective rate equal or greater.
Right. Exactly. And in this case, slightly greater. At the same time, you defer mortality. So you stop people dying right now. They're going to die 10 years later or 15 years later, but at least for the moment, they're not dying. So the growth rate rebounds right away. And then starts to come down again because that deferment starts to wear off. And if we simulate another bunch of years, I haven't done it yet, but I'm expecting this to mirror, just do that again. Yeah.
So this is a reset of maybe 10
years.
years.
10 to 15 years.
Buys you a decade.
It buys you about a decade, and that's literally all it does. It's a perturbation that resets for a decade and then slowly relaxes back to where you were.
But that's assuming that the cohort 10 years behind engages in identical behavior.
Right. And this is not going to happen in general.
Okay.
However, I think it's illustrative to a lot of people to see that this really is just a reset. That the antiretroviral thing is not a silver bullet at all. It just buys you 10 years, and then in the absence of anything else, you go back to where you were. So people really push it, but it's got a very limited time horizon.
Well, as an individual solution, it's dramatic.
As an individual solution, it's great. I mean, if I were HIV positive, I would definitely want this, and so would any other rational person. Yeah. So from a humanitarian point of view, yeah, you have to do it. But if you're looking at the population level, you've got to be aware that in the absence of doing something else, you're going to have to start over again in 10 years. So here's what happens when you do both of them. It's very nice. You get a gradual fall off in prevalence, and you get a little wiggle in the growth rate, and then it stabilizes at about 1%. So the take-home message here is that for the growth rate, you don't want to do one or the other. Neither of them are great, but together they're excellent.
So what I'm seeing here is modest flattening, and well, it is a dip. Obviously, it is a dip in incidence, and then the population growth. Well, I mean, I guess the difference is to be measured from the negative 5% that you were at before, not the down from 3.5%.
That's right. Yeah. Basically, this is still not great. We're still not at 4%. Although some people would argue that we needed to get down from 4% anyway, because 4% is unsustainable. I mean, you double every, I forget what it is, but it's in a short period of time. So 4% growth is not what you want. You probably want something that's close to 0, but on the plus side. And so this is not too bad.
So given that they were at 4% and they did not do the Malthus thing, what were the forces that were moderating the 4% growth rate?
4% growth rate is the Malthus thing. The 4% growth rate is, they were definitely on the way. What happened is that long into the past, they were near 0 because of infectious disease essentially canceling out high fertility.
Infectious disease and a lack of medical care.
So medical care and missionaries over the first part of the 20th century brought them up to 4% because that affected mortality but didn't do much to affect fertility, especially if they're Catholic missionaries. So people were having about 8-9 kids per woman that survived.
Well.
And in the past, so that's out of about 12 pregnancies. In the past, they had the 12 pregnancies and they had 2 or 3 kids that survived. So,
what is the medical impact of a dozen pregnancies, though? That alone must have an enormous health impact.
There's some of them that have had 18 or 20. They're very tough people. And there's a serious selection effect. If you manage to survive the reproductive period.
The first 5 or 6, the next 12 are really a cakewalk.
Yeah. Yeah.
he said. Okay.
It's a different regime.
Yeah.
Okay, here we've got trends in the percent of all children who are orphaned. So these are kids 0 to 15. So 15 is the cutoff. So in a normal population, this normal population, high growth, which means high fertility, high mortality, no HIV, about 5% of the children are maternal orphans, paternal, about 2.5 are maternal, and nobody is a dual orphan. And if you think of, well, approximately nobody.
An error term.
Yes, but you can see it hugs the zero line. And if you think about that, your likelihood of dying as an adult before you become an older adult is very low, and when you take the joint probability of that happening to two people, it's almost nothing. So dual orphans in a regular regime essentially don't exist, unless you have a cause of death which correlates the risk for the two parents. Car accidents, war, and HIV. So HIV is one of them. And the reason that the orphan story is such a big deal with HIV is not because it creates singlet orphans, but because it creates these huge number of dual orphans. Okay, so that's what happens. This is prevalence. Wow. This is the orphans. The orphan scale is over here. So we wind up with roughly 20% of kids 0 to 15 being dual orphans after 40 years. So that's a major societal problem in and of itself. Okay. Here's what happens with the behavioral intervention. Again, it's a quick drop-off in prevalence, continued increase in the percent orphaned, and that's because it doesn't affect mortality. Mortality is driving the orphanhood question.
Okay, so prevalence is just infection, not mortality.
Prevalence is the proportion of the population that's HIV positive.
Right.
With this behavioral intervention, you stop creating new cases, or at least you drastically diminish the number of new cases being created.
So this is going to take a generation, really.
It takes about...
To recover.
Right.
Okay.
Yeah. This, in fact, is going to take, from the time of intervention, about a generation, maybe even a little bit more, generation and a half, to get back down to normal, with an immediate 100% sainthood rate. Here's what happens with the antiretroviral. This is a very happy story. You get the mortality deferment.
It's only the 10-year story. Well, I guess it gets them out of childhood.
Right. This gets them out of childhood, which is a great thing. But past the 10 years or the 15 years, when that wears off, the new kids are going to be orphans. You're going to get exactly the same thing.
Right.
This curve is going to go like this,
right.
And then, well, actually like this.
Right.
It's going to stay like that.
Right.
Okay, when you put the two interventions together, again, you get the nice story. You get this gradual decrease in prevalence. You get this immediate decrease in the orphanhood, and it's a nice thing. Here's the more complicated thing, and when I talk to demographers, I highlight the fact that this question can only be addressed with this kind of model. What we want to do here is track the genealogy. So we want to track the relationships between grandparents, their children, and their children who are the grandparents of the grandchildren of the grandparent generation. So we need to have individual links between individual people in order to study the relationship between grandparents and their grandchildren. We can't do this with a deterministic compartmental model that just lumps everybody into one cell at each age. Okay, so here we have trends in the number and percent of adults who are 50 and older with surviving grandchildren but no surviving children. So these are older adults who have lost all of their own children but still have grandchildren surviving who they may have to look after. These two lines are the raw numbers of older women and men. These lines along the bottom are the number of them who are in this skip generation household configuration and the percent. And you can see that in a normal situation, no HIV, these numbers are very low and very stable, even though the total number of older adults is increasing as it should be. This is what happens in an untreated HIV epidemic. Two things happen. The total number of older adults plateaus and then actually diminishes. So the size of the older adult population decreases. This correlates to that negative growth rate.
Okay, is this because earlier adults who would have aged into seniority are dead?
That's right.
Okay, it's not because there are able-bodied, middle-aged people who are no longer in existence and their absence has an impact on senior survivability.
Not in this model. I don't model that link. But that's something that we need to take into account, which is why this is probably a conservative estimate of the problem. There's two things I haven't done here. Haven't modeled the impact on the mortality of orphans. Orphans are at a much, much higher risk of dying in and of themselves just because they're orphans, and so are the older people because they don't have the support of the middle generation.
That actually, the sexual behavior of orphans is also different.
It can be very different. Puts them
They're
in.
raised in institutions.
They're not raised in institutions at all. That's the problem here. So they're subject to
Predation.
potentially all kinds of predation.
Okay, so they're street children.
They're street children. They're homeless, pretty much. Qualify that a little bit. These older adults and extended family in lots of parts of Africa are doing a lot to take care of this problem, but there are what they call child-headed households, which are essentially kids who are on their own completely, and there are huge numbers of street kids in most urban areas who are dual orphans who didn't have anywhere to go.
Yeah, I mean, grandma and grandpa may not be there.
Grandma and grandpa may not be there, and your aunts and uncles probably aren't there if your parents died, because they share a lot of that risk as well. So here we have the overall number decreasing, and here the number of them in the skip generation configuration increasing. This increase starts at around the same time that this decrease starts, and the ratio of this to this and that to that is the fraction of those older adults who are in this condition. And you can see that percent goes skyrockets. Gets up to 20% for women, up to 15% or 12.5% for men. The difference here is that men can produce new kids over a wider age range. In fact, almost until they die. So it's just simply harder to get rid of all of the children of a man because some of them are young enough to have not died yet. Okay. So the behavioral intervention.
Not my plan, but
Right. The behavioral intervention has no effect because it's not affecting mortality, and this situation is entirely driven by mortality. The antiretroviral has a big effect. It affects mortality. It defers the thing by 10 years. So you get, when you combine them, the effect of the antiretroviral intervention.
and you need the behavior at all.
The problem is here that the behavioral intervention will kick in later because it's going to reduce the overall prevalence and change this transition right here as time goes by.
In the first 10 years, but it actually starts to pay just at
The moment that the other
Pretty much.
intervention
And I haven't.
starts teetering down.
We are doing these simulations in Access 97. They take forever. So I did 4, and I was doing it on a laptop. I did these while I was in South Africa, and I just didn't have access to anything. So what we really want to do, we can start them up again and do another 40 years and see that. So in this case, again, you essentially have to hit the population with both kinds of interventions at the same time, even though you don't see any benefit from the behavioral intervention for a generation.
And perhaps later you can comment about what passes for an effective behavioral intervention. I mean, I would like to know what would it take in Uganda to change to serial monogamy. I mean, what's it?
Uganda is an interesting case. What it takes, it appears, is a concerted, determined, long-term, multidimensional intervention. So you get messages from the president that say, HIV is real, HIV is a threat to our country, you need to pay attention to what's going on with HIV. You get information over the radio that tells you what HIV is, how it works, and what to do about it. You get condoms from your clinic, you get condoms from your school, you get community health care nurses who come to your home and tell you what's going on. In every prenatal care regiment, you insert an HIV prevention package so that young women become aware as soon as possible about the situation. You roll out things in primary schools, secondary schools. You enroll churches, NGOs, multilaterals, WHO, UNAIDS, all these people to do what they can simultaneously and keep it going for about a decade.
Okay, so it seems to me that the main impact then is the use the condom message.
It's the ABC is what they call it. Abstinence, be faithful, and condom.
As in, do the right thing, but since you're not going to,
Right.
Yeah, okay.
There are people. There are a few people who will do the right thing. There are a lot of other people who will do the right thing some of the time and then protect themselves the rest of the time.
Right.
And then there are people who are impervious. But it appears that most people are pervious to one extent or another.
Considering you got two chances, right? I mean, potentially anyway, depending on a certain gender politics, both the male and the female might be the ones that bring the protection into the interaction.
That's right.
So you've got some chance there.
You've got some chance. And actually, Uganda started this message sometime in the early 90s. And they are the only country in Africa that has clearly gone through a transition in the epidemic. And prevalence has been falling for 5 or 6 years, and it's down to 3-4%.
So if I remove the condom as a mechanism for engagement with this, are there any effective approaches?
Behavioral approaches?
I mean, not just, I mean, yes. Is there any, if I take the condom off the table, what's left?
Not much.
Not much.
Not much.
So the single magic bullet really is?
The single magic bullet really is educating people to change their behavior, which includes using a condom.
Okay, yeah.
In
Because
most
clearly
cases.
the condom without the education to know
Doesn't work.
where it goes, for
Because
example.
condoms, the rest of Africa is saturated with condoms.
The rest of that.
Pretty much.
Uganda is the same in terms of just availability of condoms.
Yes, pretty much. I mean, if you go anywhere in Southern Africa, it will take you 10 seconds to find a condom just about anywhere you are. I mean, there are billions of condoms in Africa, but people don't use them.
Though people do not use them.
Yes, that's the thing. Just making them available and just teaching people how to use them is not enough. People have to be willing to use them. People have to, bring them to the interaction. People's partners have to be accepting of people wanting to use them.
Or insisting, yeah.
Or insisting. The thing about the gender politics often is that, if you're a woman and you insist on the guy using a condom,
It
suggests all kinds of things that the guy's, not interested in hearing.
Yeah.
And he's not going to be.
But you're saying in Uganda they have seemed to have cracked the not only availability but the motivation.
Yeah, the motivation is the key.
And the motivation, you would argue, is simply repeated messages from authority figures insisting on the use is enough over time to actually change that behavior.
Right. Coming from everywhere with no hesitation, no qualification, no anythings. The only institution in Uganda that I know of that has really not cooperated is the upper realms of the Catholic Church, who have actually preached an anti-condom message, but it's been swamped apparently by the rest of it.
So given that we, the United States, are not in the same matrix of conditions, but have essentially taken the condom off the table as a legitimate, do not have unequivocal, uniform, regular promotion of the condom as a solution. Given that we have antiretrovirals, we have hospitals, we've got a certain number of other things that sort of contain this, what's our future?
The epidemic here is just totally different. In Africa, it's a heterosexual, generalized epidemic. It permeates every part of the population. Here, we're pretty much restricted to the homosexual population, certain small parts of the IV drug-using population, and the real issue now is the fact that it's becoming, in a small way, a heterosexual epidemic in the black population. In the impoverished segment of the black population, and predominantly young women. So that's where the real issue is right now. What's interesting here is that not only has the condom kind of somehow been marginalized, but there's a behavioral backlash of some sort going on in the homosexual community. There's this kind of behavioral disinhibition. Oh, I'm on ARTs, I'm on HAART, I'm feeling good. What the hell? There are people who are actively kind of rebelling and proactively acquiring the virus. There are people who are, just purposely not using a condom so that they can pass it or get it. There's a whole kind of array of interesting behavior going on, which has had a pretty substantial impact on the incidence in the gay community over the last 5-6 years. But it's still contained to the homosexual community. It's not really breaking out. Where it's breaking out is in the black population, and what's interesting is that that epidemic seems to be showing a lot of signs of being similar to the African epidemic, including people's attitudes toward the interventions. Suspicion, a lot of race politics, a lot of gender politics, a lot of just unwillingness to take information from other groups of people and utilize it.
So I wonder what the perceived magnitude of risk is. And so I wonder
People's
if that's
perceptions are totally off.
Well, this is what I'm suggesting, that one of the interventions is the perception of risk and the likelihood of risk and the relative magnitude of that risk versus others that are more likely. So if you think that other more violent ends of life are more probable.
Yes. I mean, your expected, basically your internalized life expectancy seems to play a key role in all kinds of risky behavior. I mean, if you're only looking at a 5-year time horizon, whether or not you're HIV positive doesn't matter.
Yeah.
I mean, if you're looking at a 15-year time horizon, it may matter, but may not.
There's a great touch in, I don't know if you picked up the Battlestar Galactica bug, but it's perhaps one of the greatest shows on television today. In it, the remnants of humanity are hard up against the wall. They may not survive. The chief medical officer is a chain smoker. And it just kind of drives home none of us are going to be here for much longer.
Exactly.
And yeah, I'm here to keep you alive, but let's face it, not for long.
Yeah. It's like smoking interventions for the above 75 set.
Doesn't work. Huh?
Who cares?
Yeah. Fascinating stuff.
So yeah, in the U.S., I don't know. The thing about the kind of generalized white population is that I think we were all indoctrinated, well, at least I was, I'm a little younger, in high school that, just don't have sex because you're going to get AIDS and you're going to die. And it's just not true at all. I mean, your probability per intercourse act is roughly 1 in 1,000 with an HIV positive person. And your likelihood here of actually meeting an HIV positive white person, unless they are gay or IV drug using, is, diminishing to nothing.
So you've got a 1 in a million of meeting the person, and then a 1 in 1,000 of actually getting it from them.
Right. But the public health strategy here was, I think, and I don't know this for a fact, it's my supposition, was to intentionally distort that risk message and scare the shit out of everybody so that they wouldn't have sex.
Well, I guess
and they worked. They worked perfectly.
Yes.
But I think
that argument, would be if you compartmentalize the risk, you get into not only the gender politics, but the various sub-community politics of essentially vilifying them because they have the higher incidence.
Yeah, you have to be. Yeah, and then you work against yourself because that confirms the the already negative perception that community had of you and your intervention.
Yeah. I can see the challenges there.
Big challenge.
What are the relative rates of all the other nastiness that you can get out there? Is it 1 in 1,000 for everything else?
Oh, STDs? No, other STDs are much more transmissible.
Okay, so
up to like 1 in 5.
The warts, the herpes, the syphilis, all of that, you can get it.
You can get it. The other thing is that if you have one of those, your probability of getting or transmitting HIV goes way up from like 1 in 1,000 to 1 in 50.
Oh, really? So it really reduces your resistance to infection?
Well, all of those things, what they do is they change the physiology of the mucosal surfaces, and they often lead to open sores, and that's just a direct route.
Opens the door.
Yeah.
Interesting. Well, I think we should all clap now.
There we go.
Sam, this is really remarkable work. I very much appreciate you taking the time. I think from the brief comment you got, you may have captured some of the reaction locals will have, which is, that's not big data.
Yes.
On the other hand, I hear your point. It is big.
But
Yeah.
that's almost a nice response to get because they're like, oh, that's not a big problem. We can do that.
Yeah, but
However,
I think you pointed to the real obstacles.
Accenture spent 10 years in the UK trying to build that system and pulled out with a tail between their legs.
Yeah. So I think the challenge is one that you identified, and that is taking expertise that is existent, but is locked up behind the high wage wall.
Yeah.
And bringing it to, let's face it, a low-wage environment, you do raise an important point. The high-quality SQL developer is rare and expensive.
Because it's a real skill. It's not easy to get that skill.
Yeah, it's not easy. I do take your point, though, and I think this is sort of like the infection charts that you've shown. What's it going to take to have an intervention that's going to cure this problem? And I would argue that the only real solution is to grow a crop. And you have to start with the undergrad and master's students right now. And so what you've done is, I think, the best behavioral intervention. Because, frankly, I don't really think that NSF is going to rise to your pay the market wage call.
They're not going to rise all the way. I think they're going to rise.
Okay.
I'm hoping that they rise. Or I'm hoping that we can convince, well, put it this way. The big funders out there, NIH, these larger private foundations, multilaterals, are beginning to realize and panic that they spent all this money to collect data that they can't use now. And they've correctly identified the fact that a big bottleneck is data management skills. And they are beginning to get very motivated.
If they include the Gates Foundation, I will say that then you do have this confluence of both the means and the method.
Yeah.
I mean, Mr.
The
Gates
Gates
has
Foundation actually
2 or 3 clues on the data processing side of things.
Yeah. That foundation actually requested this proposal from us. So
Great.
So like I said, we're kind of amateurs in this area, but we're going to give it a very good shot, and hopefully it'll go somewhere.
Because there are people here, for example, who specialize in transforming disparate schema into a common reference.
Boy, we would.
I mean, it's an open area of research in that it's difficult.
It is difficult.
But this is the kind of thing that is an active area of research here. So schema mappers
I didn't realize there are people who specialized in that.
In schema mapping, absolutely.
Really?
Oh yeah.
Because it's a difficult thing to do, as we discovered.
So, well, we'll bring the AV part of our show to an end. I think what this does point to is points for future engagement, and I think schema mapping is now our #1 goal for you, and that I think we're going to now look to try to set you up with the right people in-house. And a combination of MSR on this side of the lake and Gates Foundation on that side and UW up top.
We should be able to make things happen.
This could be the place to make things happen.
I agree. Completely.
Okay. Well, thanks so much.
Yeah, thank you. It was fun.
Come on,